Assalamualaikum and hi everyone. We are from AS1205D and today we are going to present to you about our case study, which is gas chromatography. And without further ado, let's roll.
My name is Nur Husina Naziha. This is my group members. The first one is Nur Erika Balkis. Next is Kia Shahinda. Then me, myself. And the next one is Muhammad Faris. And lastly is Nur Natasha.
Here is our introduction for our case study. All chromatographic systems have two phases, a mobile phase and a stationary phase. The mobile phase is a liquid or a gas that carries a sample through a solid stationary phase. As the sample in the mobile phase passes through the stationary phase, the compounds in the mixture will separate because of difference in their affinities for the stationary phase and difference in their solubilities in the mobile phase. In chromatographic analysis, the eluted compounds are characterized by retention times, which is TR. Qualitative analysis involves determination of TR of analytes and comparing them with TR of standards, while quantitative analysis is accomplished by comparing the areas of the analyte peaks with those of standards.
So in this case study, we pointed out three main objectives. The first one is to determine the retention time of the standard solution of the caffeine. The second one is to identify the caffeine peak in a soft drink sample. And the third one is to determine the amount of caffeine in soft drink sample using the response factor method.
For the methodology, firstly I will explain on sample handling. The syringe was rinsed before being filled with the sample. The syringe was tapped gently to make sure there is no air bubble inside the syringe. The syringe was held vertically, needle up, and the plunger was pushed to the required volume at eye level. The excess sample was removed using a tissue. For the experimental part, the instrument was switched on. The GC was set using the following condition. Initial oven and final oven temperature was set to 70 degrees Celsius, injection and detector temperature to 180 Celsius. The component sample was injected and the retention time of each component was determined individually. The standard mixture was injected and each component present was identified by comparing the retention time of each component with the retention time of each single component determined previously. The unknown sample was injected and the component present in the unknown was identified. Next, the column temperature was changed as follows. Initial column temperature to 100 degrees Celsius and final column temperature also 100 degrees Celsius. Inject the standard mixture and comment on the effect of reducing the temperature on the retention time and RS of the components. And the oven temperature was changed as follows, where initial oven and final oven both were set to 140 degrees Celsius. And inject the standard mixture and comment on the effect of reducing the temperature on the retention time and RS of the component.
Next, with me, Kia Shahinda binti Uthman, we are going to look at the results and discussion. So here, we dive into the results of our chromatography analysis. We observe distinctive peaks in the chromatograph for each substance. The standard mixture displayed peaks at 5.920 and 7.363 minutes. For 2-propanol, it exhibits a single peak at 5.911 minutes. And for N-butanol, it showed a peak at 7.396 minutes. And for the unknown sample, it had a single peak at 5.92 minutes. This initial analysis sets for the stage for a closer examination of the significance of these peaks. Moving on, let's discuss the significance of the multiple peaks observed. The standard mixtures chromatograph with its characteristic of having double peaks indicates the presence of different chemicals. This highlights the ability of gas chromatography to distinguish between various components in a sample. Understanding these peaks is crucial in deciphering the complex composition of our analyzed materials.
Now let's focus on unknown sample. The single peak observed in the unknown sample's chromatograph closely matching the retention time of 2-propanol. This suggests the presence of true propanol in our sample. Particularly, there is no peak corresponding to N-butanol in the unknown sample. This insight into the components of the unknown sample brings us closer to unraveling its chemical composition. Moving on to the next slide, as we conclude on the result and discussion slide, we summarize our findings. Gas chromatography has proven to be effective in identifying compounds in our samples. The standard mixture with its characteristic peaks serve as a valuable reference for recognizing different components. Understanding the implications of these peaks is essential for comprehending the chemical makeup of the analyzed materials. Our analysis provides a foundation for further exploration and applications in various fields.
So here is the list of references that we use for this case study.
That's all from us. Thank you for lending your ears. Bye!